Well, good afternoon, everyone. I'm Douglas with Kuker-Ranken. We're going to be starting here in just a moment, but we wanted to let you get into the room so that you can establish your audio and so forth. If you've not done one of our lunch and learns before, we ask that you turn off your video and your audio. If you've got questions, down in the bottom of your video display window, you will see a button that is marked chat. You can use that chat button at any point in time during the presentation. So if you've got questions for Brady, that's the best way to get them across. We'll also have opportunity for voice-driven questions toward the end of the event. We are recording this event, and we'll have it up on our Kuker-Ranken website. So if you happen to need to duck out early, we'll have a version available to you by the end of the week. So we're glad to have you joining us. If this is your first lunch and learn, we want to share with you that this is about a 20 to 25 minute presentation. It's not really a training, but it's a way to get familiar with some of the products and services that we offer at Kuker-Ranken. That is not a sales event. This is an information event. We also have other types of video webinars that tend to be a little bit longer and more focused than what we have going on in this lunch and learn. We do lunch and learns every Wednesday at noon Pacific Standard Time. So you can always check in on your calendars there, and you can find us on Eventbrite, where you can register for any number of the other webinars that we have coming up, or lunch and learns that we have coming up. We're also about to announce, in fact, today we're going to announce our new roadshow, where we're going to be traveling all across the Western United States, sharing information about unmanned aircraft and survey, construction equipment, and public safety equipment, along with workflows. And we're right now at a time to start, so I'm just going to turn this directly over to Brady. Brady Reisch, you have the floor.
All right. Thank you very much, Douglas. And thank you, everybody, for joining us today. We're going to be diving into the Microdrones system and looking at some benefits analysis with the system compared to other systems that some people like to compare against. And we will certainly dive in deep with that. What I'd like to preface, though, with the presentation today, everything we're showing is the raw data from the sensor processed through the appropriate processing system, Microdrones through MD Infinity, and the specifically the DJI Matrice 300 L1 sensor processed through Terra. These are standard just basic LAS point clouds that have not been cleaned up, and we'll go through and do an apples to apples comparison of them. So there's not been any manipulation. If there is anything that has changed, we will cover that on those slides. So with that, I'll go ahead and get started here. So yes, this is a real image of the Microdrone system above Allegiant Stadium, even though it is a zero grid area, easily able to fly in this area. We have a previous lunch and learn on this that we're happy to share out if you've got any questions or need that link. So a little bit about myself. Who am I, right? Why am I the one presenting this information? So my name is Brady Reisch. I am the Virtual Design and Construction Reality Capture Specialist, also referred to as a VDC for Kuker-Ranken. I am a 14 CFR Part 107 certified pilot. I've done a lot of enterprise support for some of the larger companies aircraft-wise on the unmanned. I'm also a UAS instructor with Sundance Media Group and a Pix40 instructor, so very versed in photogrammetry and now LiDAR. So that's kind of why I'm here speaking to you. Now, really what we're here for is get into the nitty-gritty, right? We want to understand and take a look at all this information. So we're going to go ahead and jump right on in. So this very first comparison that we have, I'm going to give you a little bit of background. So we were recently at the Elko Mine Show 2022 in Elko, Nevada. So we had put up the DJI M300 L1 sensor and scanned the area, as well as putting up the Microdrone 1000 HR. We thought this would be a very great test to look at the differences between the two data sets and do an actual comparison so you can look at all this information. So very first, everything on the left-hand side of the screen is the DJI L1 or the M300 L1. On the right-hand side of the screen, kind of that gold color, that's going to be the Microdrones 1000 HR, which is the entry-level system. So on this very first image, as we're looking at, this is a program that's called Leica 3DR. This is the system that we have imported both of these LAS files into to make an apples-to-apples comparison rather than do two different software to compare the data. So in the same software, two different projects open side by side. A lot of the images we've tried to go through and line them up. So if they don't line up 100%, I apologize. It's difficult to get the exact same angle, but we've done our best here. You will see that we've got some pretty good information, and from afar, we see some pretty good information on both sides, from the L1 and from the microdrones. But when we start to dive just a little bit deeper, let's get in just a little bit closer. What you'll notice is everything under the DJI M300 L1 looks like there's more points. And there certainly are a lot more points that are available through that system. So it looks like it's filled in a little bit more. On the right-hand side, you'll see there were some tents here, and there's a trailer. If anybody's seen that, that is our aerial vehicle operations center that we pulled up to the show with us, just to the north of, or to the top of the tent. But you'll see on the ground, it looks a little more sparse with the microdrone's data. But we're going to dive in even further and see what that difference is. So zooming in yet again, and we're looking on the bottom of each of these images, you'll see that there's a little bar for about 2 feet. So we're looking at maybe 15, 20 feet between side to side on these images. What you'll notice is that on the left-hand side with the L1 data, we have really sparse information on the south side and really dense information on the north side of this tent. Both drones flew the same grid pattern. We went east and west and north and south. So this is just really interesting to see how some of the data is densified and some of it is sparse on the L1. Really not a whole lot of rhyme or reason to it. It just depends on which direction the drone was flying. On the right-hand side with the 1000 HR, we see that it's very clean and consistent information, which leads us to believe that it is more accurate to look at that data, right? Something that is actually measurable. So moving up just a little bit, this is another good example. And what I want to specifically point out is, as on the very, very top of the image, it starts to break apart on the microdrone system. This is because this was not the intended flight path. So there's less data on that road just on the top end of that. On the M300, it required a larger swath area to fly, which is why we have a little more densification on that road. So that's not the subject or what we were attempting to shoot in this specific scenario. But this is really where you'll start to see the huge difference between the microdrones and the L1 sensor. So on the left, starting with the L1, you see there's a couple holes. This is actually where there's vegetation or where there's trees coming up. So we're not getting a lot of penetration. And I want to clarify, when we say penetration, we're not talking about through leaves or through something. We're looking between the leaves, between the branches to basically touch the ground and come back into the sensor. So as the L1 sensor is flying over the top, we've got some information from the tree over the top. However, because of how dense the tree was, there's not a lot of ground information underneath. So if we were to strip this apart and look for a surveyor, we're missing information near the base trunk or near the ground. With the MD1000HR, we've got a lot more information underneath those trees. We don't see the same holes. There's a couple holes on the concrete, but that's because we had some dumpsters and some trucks, so it's not going to penetrate through that. But specifically the trees, we've got really good coverage under that information. So diving in a little bit deeper, we'll get some better images here. This is, again, trying to get to the same angle. And it's hard to determine the depth on this specific angle. So we'll go into another one here, but you'll see there's a lot less data underneath with the L1 sensor than we do with the HR. So if you have any sort of vegetation, the microdrone system is going to be a better bet. So trimming this down a little bit to make it a little more clear, you can still see we've got information on the tree. There's really not a lot underneath. And if we change that view just a little bit, rotate it around, you'll see that, yes, we've got information on that tree, but again, the ground, there's nothing there, right? So as we're going to create a surface to create contours or anything else you might need for a survey, there's missing information. So the system has to now try to fill that hole and put a I guess just a flat area in that space because it can't determine that there's any elevation according to that. So I hope that that's coming through on the screen for you guys so you can see it pretty well.
Looks great on this side, Brady.
So zooming back a little bit, we'll see that there are some white squares here. This is where we had just cut that information to show it's the same tree in the same area that we're looking at. Just to show you we're not playing around. We're not picking up different trees to show, one's better than the other. We're showing actually what we had captured, right? We want to prove that this is the same tree we were looking at before with all the same settings. Now, what we do with LiDAR systems is we want to make sure that all of our points line up very tight and nice, right? So the thickness of the cloud, we want it to be very, very minimal. If we have really big, thick clouds, it means that there's a lot of noise that we need to then address and take a look at. So the next slide here that I'm going to show you is actually just taking a thin strip in the same spot over that same tent canopy just to the south of the AVOC. So we'll pull that up. And what we're doing is we're essentially slicing it out, getting rid of everything behind and everything in front so we can see a real thin strip and see if everything lines up. So what you'll see on the left-hand side with the L1 sensor, on the left-hand side of the tent, you'll see that you've got the peak of the tent and it starts coming down. And then we have another layer essentially hovering over the top of that. What that is telling us is that when we had more densified information, remember a couple slides ago when we were talking about that, there's more information in one spot. However, those are not synchronized together, right? So this is something we refer to as a strip adjustment in this case. So these strips, for each time that the drone flew over this area, are not lining up for some reason, right? Using the same parameters for each flight, using their own respective application and controllers, we're not able to have those two lined up. Now, you can do some manipulation, but it's going to take a lot more time in the office to resolve that. And what happens is when you don't have those strips and when they're not aligned, you have a lot of noise, which means it's going to cause issues moving forward when we start doing our surfaces or start doing any of our contours from there. And you'll notice on the right-hand side with the microdrone data, little bit harder to see because of the color, but that gold color, we've got a nice clean strip of where the tent is, of where the ground is. It's just cleaner data, right? We're not throwing spaghetti at the wall to see what sticks. We're getting usable, actionable data, which is exactly what we're looking for in this type of an industry. So again, using the Leica 3DR system, we've got the same parameters essentially. What we're doing in this instance is splitting the ground points. This is just to show us what is ground and what is not ground. And the reason why I left the slide in here is I want to show you on top of some of the roofs, you'll see that there's some green spots on both the L1 and the HR system. This is the Leica system not recognizing that that's a roof and that it thinks it's something to do with the ground. So we have to do a little bit of manipulation to close out those points. So I just wanted to show the slide specifically showing all we're doing is taking out the roof aspects for both of these models. So then we can start getting down to the ground and see exactly what we can get from there. So with doing some of the classification, we do have a cleaned point cloud in both of these systems or in both data sets. So we've cleaned out some of the roofs at this point. You'll see that there are a couple different limit boxes here set up as well. But you'll see that the DJI M300L1 had wider information and more information towards the sides because it required that the drone flew further than what the microdrone system required. And with that, what you will see is really the flight time is a pretty big factor, depending on whether you wanted to try the M300L1 or the microdrone MD1000HR. The flight time difference, the L1 was 2 to 3 times longer just in flight itself to acquire this data, not including any updates. And I know a lot of you here today have drones, and when you get updates, they take a little bit of time. So with the L1, it took significantly longer, but we're going to throw that out at this point. With the microdrone system, you're not required to do those updates. So if you get an update out in the field, you can say, you know what, I'm just going to do that back in the office. It's a great way to make sure you're not prolonging your time out in the field. So the next slide is now we have a surface created. What you'll see here is really where this starts to fall apart. On the left hand, again, you've got the L1. So all the holes that we had from underneath the canopy are filled in, right? It assumes something is flat in that area, tries to go to the closest point and creates basically a triangle mesh around that. So this is our surface. And what you'll see is that the surface has some contour or some deviation in the ground where the parking lot sat versus where the road asphalt was. So we have far less detail using the exact same settings through 3DR in order to process this mesh. And just ignore this little hump in the center. I think I left one little point that I didn't see before. But aside from that, there's no other manipulation here. On the right-hand side, we'll see the microdrone system. And you'll see there's a big flat area. There's a large giant tent right here. There's no way that the LiDAR could penetrate through the canopy, which is why it's flat in that area. But you'll see in the parking lot, we have a lot more of the divots, a lot more of the true information on what actually happened. We can see where the sidewalks are. We see a clear curb difference in the two different data sets. And then finally, once we have some sort of a mesh through that system, we can generate our contour lines. And again, we generated the same contour lines. And what you'll see is on the left, we've got more smooth line detail information. On the right-hand side with the Microdrones 1000 system, we have finer detail. And you can always smooth these lines in whatever program you're utilizing. But we wanted to show you apples to apples, as close to the same view as we can between both of these data sets. Both of these sets were shot. There were 2 separate days that they were captured on due to updates and time constraints, but it is of the same area. So some of the tents and things might have changed between the 2 data sets, but the ground itself did not change. So with that, what I'd like to show you is one more data set. It's not really a comparison, but I want to show you what you are able to get real world with something like the microdrone system. So this data set was captured for a public safety or a public utility department, trying to look for a demonstration of the capabilities of this type of an aircraft. So as we look around, again, this is the Leica 3DR user interface to look and see things, right? We're not manipulating the data. We're just going to obscure some things, take some things out like the vegetation and things like that. So I'm going to rotate this around and zoom out and show you the scale of what we had captured here. So if you were with us just about 2 months ago, we've shown this data set. So I'm just going to show it again because I think it's a fantastic way to look at this information and see what there is. So right here, there's a big black line coming down here. This is actually a river running through this little valley. And then north to south, there's a road and there's a bridge right over the top. So just for scale, so you understand what we're looking at there. This is in the middle of a forest. So of course we have a lot of trees, a lot of canopy cover. And I want to change this color here, and it might make it a little easier to see for just a moment. So all the blue points on the ground are going to be lower in elevation. All the red points on the top are higher elevation. So you see we have lots and lots of trees right in this area. So it's a little bit of a pucker factor trying to fly here, but we were able to capture this. So with this type of a system, let's just turn on our clipping for just a moment here. We were able to capture this bridge information using the LiDAR system with the 1000 HR. So we're able to capture, and if we rotate this around, you'll see that this is 3-dimensional. We captured the top and the bottom because there's a grade over the top of this, this little bridge that you can drive over the top of. But we were able to capture the information because the laser could see down below. So we have information down in the valley, and then we've got the running water down below underneath of that. So some of the other details you're able to pull out of using basically a LiDAR data set is something with your power lines. So let's turn off our bridge here. I'll turn on our power lines, rotate around. We can capture sag of the power lines. We can see where the poles are. We can ensure that everything is straight. And at this point, it looks like it curves down the road following the access roads. So there's lots of information we can pull out of this and really, really dive deep into this data set. Now, we are short on some time, so I don't want to take too much time at this point, but I want to give you a couple examples on what we had. The other thing I was going to show you real quick is the mesh. If we turn off this, I'm sorry, one moment here. We've got a mesh with some pretty good information retaining in here. Of course, the access road coming up, we've taken out the bridge to show this information. And then from here, once you have your mesh, you can create your contour lines, which are all three-dimensional in this case. And but of course, there's many, many different softwares that would allow you to utilize this. We love 3DR because you can select this area, send to, and if you have Civil 3D, for example, pulled open, instantly get all those 3D contour lines pulled over into whatever type of a program or BIM environment that you would like. So a very, very powerful tool combined with very powerful hardware for microdrones and the software to be able to process all of the LiDAR data. So with that, what I will do is close this out and finish up and ask you guys to go ahead and put in any of your questions you may have in chat. While you are typing those in chat or getting ready to ask questions, I did just want to cover, Douglas did mention our Kuker-Ranken Roadshow 2022. We're very, very excited. So we have a lot more cities that we're going to go to. So we're going to be very busy between October and November. So make sure to take a picture of this. We can send information out as well. So if you would like to know more about that, certainly let us know. Reach out to your local representative. We'll make sure we get you signed up and get into one of our roadshow cities we will be coming to towards the end of this year. So with that, Douglas, if you want to come back and we'll just see if we can address anybody's questions. Martina, so we're happy to go through to discuss that. Really not something that we can dive into right now. It takes a little bit of time to explain what some of the pricing is. So make sure to reach out, and we're happy to go through all this individually as a one-on-one basis. If this is something you are interested in, whether it's a DJI, whether it's Autel or a microdrone system, or some substance that may be coming out later on. We'll leave it at that.
Yeah, there might be an unidentified drone somewhere on that particular page that folks are looking at. But Martina, you can count on, you can get into basic LiDAR systems starting as low as $45,000. And prices can range really as high as you need them to go. Mm-hmm. The reason that there's some variables in pricing is because there may be some different software tools, different payload tools, and other things that you want to do with them. But rather than having a fairly long, complex conversation, we try to avoid those in our webinars if we can. But if you want to reach out to Brady or myself or any of the other folks at Kuker-Ranken, we can give you spot-on pricing on any of the models that you might be looking at. Real quick, as we're waiting for a couple more questions to come through here, I'll just read off the list of where we're going to be for those of you that are out there that maybe can't see this on your mobile device. We're going to be in Seattle beginning on October 3rd, moving to Tacoma, Washington, or Fife area. From there, we go to Portland and then into Bend, Oregon. From there, we'll be over in Spokane, on our way over to Boise. So we're in Boise on October 12th. October 14th, we're adding Idaho Falls to our tour this year. We did not do Idaho Falls last year, but we've had several requests. So if you're in that locality, you're welcome to come join us. Then on October 17th, we're in Salt Lake City. From Salt Lake City, we're going to another new city for us. This is Reno. And from Reno, we drop to Sacramento, where we are partnering with one of the construction schools in that area. And on October 25th, we'll be in Las Vegas. October 27th, we'll be in Phoenix. November 1st, we'll be in St. George, Utah. And on November 3rd, we will be going to Fullerton, California. So we would love to see you at some of these locations that are coming forward. Next up, I'm not seeing too many questions come through, so I'll just announce what a couple of the other upcoming Lunch and Learns are going to be. First off, on July 20th, we've got Matt Kowalski. He's going to be talking about the new features in Cyclone Register 360. You had a little bit of a preview of part of that just a few minutes ago. On July 27th, Brady and myself will be doing an introduction to the Leica BLK to Fly, which is a very task-specific LiDAR-focused or scanning-focused drone system that you can see on the screen there in front of you. On August 3rd, we'll have Rob Mitchell talking about the Leica GS18I, a fantastic tool for surveyors, whether you're as well as for construction folks. On August 10th, we've got Matt Kowalski again. He'll be doing a workflow between Autodesk Revit to Leica Infinity, all the way out to Captivate. On August 24th, I will be doing a presentation on a new aircraft that you haven't heard much about yet. This is called the MapTech Aquila 1 drone, and this is just being launched in the United States. It's a NATO compliant or an NDAA compliant drone. So for those of you that have got workflows or work partners that prevent you from flying Chinese drones, this is an outstanding opportunity and a product for you to have a look at. So that gets us through our list, and we're just about out of time for our Lunch and Learn. I'm looking for any new questions to come through. If you've got any, this is the point where you'll want to ask them. And here's Brady's contact information. Again, we are a service, equipment, software support, and training company. So we are a full 360 solution for you, whether you're flying unmanned aircraft, you're working as a surveyor, construction sites, if you're an engineer, et cetera. We've got products to take care of you. Brady, you want to take just a second to wrap here? We're not seeing any new questions come through.
Yeah, I'm not seeing anything else come through. But if you do have any questions that we're not able to address today with the live Lunch and Learn, make sure to reach out. So all my contact information is on the slide right now. So breisch@crink.net. You're more than welcome to call my cell phone or my office phone. I will be answering both of them. And really, I think that should be it for what we have today. So I just wanted to say thank you so much, everybody, for joining us. Really appreciate it. Douglas, thank you so much for emceeing for me today. I really appreciate that as well. And we look forward to seeing you guys on the next couple Lunch and Learns.
Thank you, everyone, for being with us today. Be safe out there. We'll see you next week.